Hello, this is Introduction to Kotlin. My name is Dmitry. I am a JVM developer, so I don't necessarily know a lot about .NET, so I was wondering how many people are .NET people? Oh, cool. And how many know about Java? Oh, also. But I'll try to refer to C#, but if I'm wrong, just correct me. Just in case, all the stuff that I'm showing, including slides and code, this Dropbox link, so you don't need to necessarily take photos of slides. It's all there. So since there are some people know, you know what Java is, of course, the right answer, it is an island. So somewhere in Indonesia. It's quite big. Never been there, but there are nice, Java C. So there is, if you don't know, Java C is Java compiler, but there is also Java C as a C. So nice photos of this island, some volcanoes there. Never been, but obviously you should know what Kotlin is by now. It is an island. Zooming in, not far from St. Petersburg. It's much smaller, and there is no Kotlin C. Sorry. There is Kotlin C as a command line tool, but no C. So that's the photo from Kotlin. So in reality, Kotlin is statically typed pragmatic language for JVM and JavaScript right now. So what it means statically typed, I guess self-explanatory, it's like C#. Pragmatic means the Kotlin team didn't try to use some new features. They tried to create a usable language right now without too much experimentation. That's compared to Scala, let's say. And for JVM and JavaScript means that Kotlin can compile to multiple platforms, that's the latest feature. And it was originally created for JVM, now it compiles to JavaScript. It works quite fine, but there are some, with JavaScript, I'd say it's less mature. There is also Kotlin native, which is not released, but it's usable and can bugs. So Kotlin is open source, it's all on GitHub. It's not open, it's Apache 2 license, so anyone can contribute. Based on this repository, that's very short history of Kotlin. So you can see that's 2011. This is where it was started. So just show horizontal line. This is time, vertical line amount of commits per month. So that's the beginning, and that's until 2018. So the first release was over here, 2016. So unlike JavaScript, which allegedly was written in 2 weeks, Kotlin was written in 6 years. So in reality, what was happening, JetBrains were trying this out, and before releasing number 1, I think there was this message, they removed lots of features. And that's why the language is pragmatic, because they didn't put all the features in. They put only the features that they were sure they need right now. Or the problem is that once you added the feature to the language, it's very difficult to take it out of the language. And so once you added too many, they all interact in very complex ways. It slows evolution of the language. So this is why they removed lots of features like tuples. They don't say no to them, they say not right now, maybe later we'll add them. And so that was version 1. And then the next version with coroutines was beginning of 2017. And now, recently before the year, was 1.2 with multi-platform support. So now it's officially, you can compile the same code to JavaScript and JVM within one project. So that's similar thing, but vertical bar is the amount of committers per month. So you can see in the very beginning that I had 2 people committing, and now way more. And I think that here is the spike. It's probably after Kotlin was approved by Google for Android development, so maybe more people started contributing externally. And I haven't really checked this data though, so if you analyze the Git commits, you can prove me not right, or prove me wrong. So why not C#? But in reality, if you're developing right now on .NET and you're using C#, then just don't use Kotlin. I mean in production, right? Because it's very different platform. I mean JVM is very different, so you probably shouldn't switch. So, but if you want to have fun, of course you can. So why not Java? In short, Java evolves slowly. It takes ages. My favorite example, semicolons. There was a panel with Java architects, and there was a question: when is there a chance semicolon will be removed? And the answer was technically it can be done, but there are so many other things. So in reality, it's never going to happen. So basically, I don't know about C#, but it's probably also there forever, because there are always more important things to do. As you can guess, there are no semicolons in Kotlin. And so why not Scala? It's Scala wasn't that pragmatic. They added tons of features like XML into language baked in, and went a bit too far, so now it's difficult to fix. And why not Groovy? Because Kotlin is a bit inspired by Groovy, C# and Scala. because it's dynamically typed, and the argument goes that for large projects, when you have 100 people working for 10 years, then you kind of want static types to know if you broke things. So, and Kotlin has its own features, which I'll show in a minute. So this was a quick talking bit, and then I'll show examples in actual IDE, so because I think it's a much better way to understand what it really is rather than just look at some slides. So we should start with the hello world thing. Oh, I just realized I was away from microphone. Good. So this is hello world. So just to show, this is just IntelliJ IDEA. So you can see it's like there is this panel, and it's all running in presentation mode. This is why everything is so big. So if I run this thing, hello world, as you can guess, it will print hello world over there. Right. So what's going on here? Fun is a keyword. Main is entry point, like in all C languages. The text args, which is arguments passed from command line. Array is array of inputs, and return type is capital unit, which is like void in C# or C. So unit is optional, so we can kind of drop it. Then curly braces, classic thing. Then println, if I click on this and go to source code, this is in Kotlin IO, it's basically Java system out println, so there's nothing magical going on. And as you can guess, this is a string literal, which means semicolon optional. So as you might also notice, there is no class, unlike a C# or something. There is no class surrounding the main function, so you don't really need a class. So to show what this, so I can, one other thing I can do this is extract message. So what's going on here, this is $ and message, this is string interpolation, and full syntax for this is concatenated string, right? I can also do raw string literals, or in C#, I think they're called verbatim. So if I run this, it now will print on 2 lines, on separate lines. So I'll undo these changes. So the type of the message, as you can guess, there is local type inference, let's say, unlike Java. So if I specify type explicitly, that's the type. So you probably notice here, args, the syntax unlike Java and C#, so you say the name of the variable, colon, and then type. So here type is Kotlin.string. And if I look at the bytecode of this thing, you can see that it kind of becomes, well, let's look in here in main. This is decompiled code, which I showed, and this is highlighted a bit, is what it actually becomes at runtime. So this, at compile time, it's Kotlin.string. At runtime, it becomes Java length string. And in this way, it's similar to C# when you have, for example, your lowercase int, and at compile time, and then runtime it becomes int32 or like whatever. So in a way, it's just copied thing. And in a similar way, so if I click on this string, for example, it goes into Kotlin. So it's defined in Kotlin source code. And if you run it on JavaScript platform, it will be compiled to some JavaScript implementation of a string. So this is how it compiles to multiple platforms. So here type is, for this message, this type is not necessary because there is type inference. So here you can see the syntax is val message. So val means it's read-only. So if I want to assign something to it, it's going to be compilation error. So it says val cannot be reassigned. So I have to make it var, which is just like C# syntax. Believe, then it can be reassigned. So I'll undo this bit. And I'll extract this as a function. So let's call it greetings. So what's going on here, I extract a function. So there are several modifiers. So public is also default. The interesting thing that it was the other way around originally in Kotlin. Before release 1, default was private, and you had to specify public explicitly, but then they changed their mind. But after analyzing Java code bases, the statistic was that there are way more public methods. So they just decided to save on typing. So unlike Java, there is no protected, but there is internal thing, which should be familiar to C#, which means it's visible only within this assembly or compilation module. So I'll remove all of this. So this is a greetings function, which takes a message of type string. And this is the full syntax really is this, so more familiar curly braces, and then return and this string. But there is also expression body, just like C#. But if it's one method, you can drop return type like this. So this is similar to C#7, I think, expression body. So here, like one more similarity to C#, there are extension functions. So what I just did was refactoring, which I'll do it again. So it basically moves this parameter into here. So we pretend that string has a method greetings. So in println, we can say message.greetings. And inside this interpolation, we refer not to argument, but to this. And this will mean a string. Again, if we look at bytecode, this is show Kotlin bytecode. We can see these greetings really is just that's the line. It's just a static method which takes one argument, so it is really just syntactic sugar right now. So it's equivalent to this. But it makes a big difference, surprisingly big difference once you start using it quite a lot. What I mean is just a static. There is no interpolation based on extension methods, nothing like that. So it's just a static. I'll undo this for a second. Yeah. So also, unlike a few languages, you cannot reassign arguments to functions. So it says val cannot be reassigned. We could try var, but it's also an error. So we basically cannot reassign arguments, quite strict in terms of that. So again, similar to C#, we can have default values for arguments. Unlike, so I'll do default. If I run this, it will print NDC here. Unlike C#, this is not just compilation time value, it can be just some function to uppercase something. So this will also work. So it's a bit more flexible. Similar to this, there can be named arguments, so I can do message, and inline message. So this is a bit more convenient, so I saved one line. So named arguments can be good. One more trick with extension methods, functions, is that we can do something like this, do fun, printed, and say this, and println this. No, so we can say any, where any is like object, and then instead of greeting, we can do printed, this kind of syntax. So it still works, just prints hello world. The interesting bit comes when we can have nullable type, and we can say null.printed, and it will print null, and it still works. But just because, as I saw, it converts to static method, you can print null. It's okay. And to make things a bit more complicated. No. So it's what I showed is there is nothing special to it in terms of JVM. This is very standard. This is just running on normal JVM, compiling to normal Java code. This is why it interacts with Java seamlessly. So all the strings and numbers, they interact with Java. So what I'm doing here, some Java class, calling static method on it, and then it just called printed method, which I just wrote. If I click on greeting from Java, you can see this is actual Java because there is semicolon over there. So it's just basically interaction between Kotlin and Java. So to show the whole project, it's pretty normal Java. It's compiled. There is POM.xml if you know Maven. That's huge Maven definition, or the same definition in Gradle. So basically, all you need to start using Kotlin, I guess, is this line to add a Kotlin and apply Kotlin plugin, and maybe Kotlin repository. So it's like few lines added to a Gradle, and you can start using Kotlin straight away. So that was intense Hello World. I'll switch back to Hello World. So this is what we looked at. It was basic syntax, string abstraction, val, var, named parameters, extension functions, and integration with Java. If you want me to go back and type something, just give a shout anytime, or any comments, or whatever. Okay, because it was intense Hello World, here's a random joke, has nothing to do with anything. So the question, what comes first, chicken or egg? And there is scientific answer to it, like definitely egg comes first, because there were animals before chicken which had eggs. So that's why chicken always comes first. Right. So this was Hello World, which was kind of all about strings and printing strings. Now moving on to the next primitive, which is basically numbers, so factorial. Just as a reminder, factorial, that's the formula. I assume everyone knows what factorial is. So I switch to factorial thing. So that's an example of factorial. It's, again, main function. So that's main, inside main, thing I didn't show, functions can be defined inside functions. Again, it's already done. It's like, you cannot do it in Java, but you can do it in C#7, as far as I know. So I'll move this factorial out of main. So inside main, we print factorial from 0 to 5, like this. So if I run this, it should print something. So yeah, looks right to me. Then the implementation of factorial is this naive recursive implementation. So again, fun is keyword, factorial is the name, n is an argument, has type int, the whole function returns type int. So if n less or equals than 1, then we return 1. Otherwise, we call factorial for n minus 1 and multiply by n. So it all expands to this formula which I showed in Wikipedia. One thing which I will just do a quick cleanup. One thing is that if is an expression in Kotlin, so return can be lifted out of if, so this is a valid thing. It's kind of, I guess, a good decision. I really like this design. But there is right now no ternary operator, so there is no way to do a ternary. There is another thing in Kotlin which is kind of switch statement. So there is a transformation from if to when clause. And when clause means if n less than 1, then it's 1. So it can be multi-line. That's the full syntax. And else we do this recursive case. I don't think it's a good idea to go down this path this way with this code. So I'll just convert everything to one line and be happy with this. So similar to what I showed before, this int is actually, if I navigate to it, this is defined in Kotlin primitives. So this is a Kotlin.int, the full type. But as it says in the documentation, on JVM it becomes lowercase int. So it's again a similar idea that there is Kotlin compilation type, and then there is at runtime it becomes platform type. So if we look at bytecode, it should be again just Java. This bytecode, capital I means it's a lowercase primitive int. And again, it depends on platform. On JavaScript, obviously there are no ints. I'm not really sure what's going to be, maybe a float. So never really checked. So obviously this code is not correct. So if I put 17, the result is negative, which is definitely not correct for multiplying several positive numbers. So the problem is the same, I guess, for .NET environment, that this lowercase int silently overflows and becomes negative. So that's clearly wrong. So, and there is obvious answer to use something like big integer or big decimal. I'll use big decimal just because it's a bit easier to do in terms of changing the code. So basically this big decimal, as you can see at the top, is just Java math big decimal. So it's normal Java class. So here, unlike, let's say, C#, there is no interpolation for types. Kotlin is quite strict, so there is no widening conversion, no narrowing conversion. And in a way, it makes perfect sense because it makes the whole type systems more straightforward, because you have int and lon, they're all subtypes of a number, but int is not subtype of a lon, so you cannot just convert them to one another. So here, I need to change all of this. So say like that. Now if I print it, it should print like some positive number. I think that's correct. Right. So before I move on, this is 2018, and clearly I shouldn't be doing it in main. I should write a test. So I'll start with a class called like factorial tests. That's another interesting thing, which not related to Kotlin, but there is an argument that all test classes, calculate, they should be called not just test, but tests with S plural, because you usually have lots of tests inside. It's like nobody uses it in convention, but it only means that everyone is wrong and this is right. That's what it means. So here what's going on, I defined a class in Kotlin, and inside the class there is one function. This is @test is an annotation from JUnit. So again, it's just using straightforward this org JUnit, using annotation from JUnit. In C# this is attribute, I think. And then the interesting bit here is that this backtick notation, it means that you can use spaces in functions, really useful for test names. So yeah, so it's just absolutely normal name. So you see it appears in autocomplete, so it's just normal function. Like, it's not a very good idea to use in actual code, but for test this is perfect. So I'll just move all printlns into here as a first step, run it again. So you can see now it runs inside this JUnit runner in IntelliJ. So the reason it works is because it compiles to normal bytecode, which uses this annotation from JUnit. So it's not different from Java. From unit tests written in Java, this is not different. So in this sense, it's the same way Scala or Groovy languages work on JVM. So here I need to, I guess, also rewrite assertions. So I'll do this, assert that, and then equal to something, let's say big decimal 1. So I need to import the right one. There are 2 Hamcrest implementations, one with K and one is normal. I'm using here with K. K means for Kotlin. Very clever. So I guess this 1, 1, 2, 6, 1, 2, something like that. No, that's wrong. It's really 24. And the last one, I just don't remember. So now we're fine. Yay. So it was a bit, it's like going back to the factorial with big decimal. What I changed is types here, and I changed this 1 to big decimal 1, this constant. And everything else just worked. This may be okay for C#, but for Java it's unusual because there is no operator overload, and all languages after Java on JVM, well, like all popular languages, they added operator overloading, not excluding Kotlin. So all of these minuses, so if I actually put the whole thing, this is the actual function name, minus, and this is how it's defined for big decimal as extension function. So big decimal is a Java class, but you can define extension function on a Java class. This is how all APIs are extended. And then there is convention. If your function is called minus, you can and it has operator keyword like here, then you can replace it with minus. And this is the same goes for multiply, less than, and so on. So it would be nice though to not have this big decimals, but I have something like that. Okay? So I'll try one here, for example. So we could do n minus 1. And 1 here is going to be integer value. So what is wrong here is that it's just there is no such function, but it's easy to create. So basically that's the whole thing. Return good big decimal and with this minus and convert it to expression. And so now this will work. So what's going on here is that we defined extension function on big decimal called minus, which takes integer as an argument. Then we just wrap this n into big decimal, and that's it. We can do the same with this, right? But I won't go down there. So as you might guess, this is still wrong, because if I do factorial big decimal, let's say 30,000, then there is a nice thing like in Java 7. You can do underscores for readability. It doesn't do anything. It's just to delimit the numbers if it's big. So as you can guess, this is just Stack Overflow because 30,000 allocates too many frames, so it just explodes. So there is, to solve this problem, is normally you can do tail recursion optimization. And there is a way to do it in Kotlin. There is a keyword called tail rec. So I added it, but like everything is highlighted as yellow because Kotlin can see it that it's not tail recursive. It can analyze source code and understand that it's wrong. And I think it's a good thing. I think in C# it happens on platform level, not on language level. And you kind of don't know, did it actually work or did it not? So I think this approach is a bit more clear because it can kind of help you to figure out if you're not doing what you intend to do. So it should be easy to fix. So I'll do like result of type big decimal. Default is 1. Here we'll return result, otherwise to n and result by n. I think that now you see this warning disappeared, and so it should work. Yay. So I didn't ascertain this, but you see this nice small number. Looks correct to me. Right. So this is complicated factorial. Just to show one more thing, I'm not going to go into details about this, but there is also the other thing, which is coroutines in Kotlin. And I believe this is the right way to write factorial in co-recursive way. This is maybe great annoying interview question. People might ask you about recursion, but what about co-recursion? With my understanding, this is basically co-recursive implementation of factorial. So what's going on here, I'll quickly show. So this is the code you would write in C# with yield keyword, and which just returns you infinite stream or sequence of integers. Like integers are on here, obviously should be big decimal. But anyway, so the whole idea is that there is while true, and then it yields, and at this point, this execution stops. I'm not going to go into details of how it works. The interesting thing about Kotlin, and why I mentioned this, is that yield is not a keyword, it's just a function. So Kotlin also has coroutines, but they implement it at a lower level of abstraction. So yield is just a function, unlike C#. But as I said, not going into too much details. Feel free to chat to me later. So that was intense factorial. This is what we looked at. Well, one thing I forgot to mention, all these big decimal instantiations, these are constructors, so what is being called here is constructor from Java math, but there is no new keyword in Kotlin, so you don't type new at all. In a way, it makes perfect sense because you can think about constructor as a function which creates a new instance of your object, so maybe it's not, why have different syntax for calling almost the same function? So yeah, this is what we looked at, int, lons, all numbers are objects, no new keyword, operator overloading, tail call optimization, unit testing. Because it was difficult, that's a random joke. So what it says is that from technical point of view, glass is never empty because it would be empty in vacuum, but we don't live in vacuum, and it's difficult to get vacuum, so it's always full of air or full of water, and doesn't matter. Very optimistic. So, and the final thing is data munging code kata. So code kata, the whole idea of kata is it comes from martial arts, where people repeat the same exercise or the same move over and over again to perfect it. So the same idea was popularized by David Thomas, who wrote this book, The Pragmatic Programmer. And that's the website. It used to look much more serious, maybe 10 years ago when I looked. Now it's with cats. And there are some examples of programming exercises, kind of code katas. So the idea is that you do it over and over again. Maybe you use new shortcuts, or you use different editor, or do it in a different programming language, or do it with time limit, something like that. So I'll do one in Kotlin, which I think kind of shows, touches on enterprise development. So that's kata number 4, data munging. So the whole kata is about reading and processing files. So part 1 is to read a text file and find a day with minimum temperature spread. So there is a file which I'll show, and we just get the lines, then parse them and find the number of the day for which temperatures recorded in this file has minimum difference. Then similar thing for football, and then trying to remove duplication from both solutions. I'm not sure we're going to finish this, probably, but it should give the idea of what it's like to write actual enterprise code in Kotlin. So this is the file. That's the weather text file. I'm not sure what this thing is at the top. It's like in typical enterprise development, you get some file from somebody, nobody in your company knows what that means, but you know about these 3 columns. So this is the day, and this is maximum temperature on the day, and this is minimum. And there are just 30 days, 1 month, so it's quite small. In real enterprise, it would be like maybe 500 megabytes. So that's data munging kata. So this is, again, some code written in Kotlin test framework, which is different testing framework. Previously, we were using JUnit, pretty much like it is in Java, but this is Kotlin test. I'm showing it just to show something different. So to start with, quickly, I'm just trying to read the file in the first place. So what I'm doing here is using Java IO file. Again, there is no new keyword, so here we're just like creating files. Then we can do read lines, and then for each line, for each println it. So what's going on here is that I'll just run it and see if it works at all. So as you can see, it prints back the actual file we looked at, so at least this bit worked. So here we just create file, then we do read lines. There is no actual function on Java IO file. So if I click on this, I can see this is defined in Kotlin IO. So it's again extension function. This is how Kotlin extends Java APIs. And this returns a list of files, so a list of lines. So if I extract this into lines and I specify type, you can see this is list, and this is type argument string. So then we do .forEach. As you can guess, this forEach doesn't really exist in Java. So this is, again, extension method on iterable of type T. This is how you do generics. Then forEach takes one argument, which is action. Action is a lambda of this type. So this is syntax for specifying type of lambda. Its input is T, then it returns unit, which means void. It just does some side effects. So and here it does println it. The actual syntax for this is that, like that, but because lambda is the last argument, then we can drop parents. This comes like from Groovy and Scala, so that's normal thing to drop parents if lambda is last argument. Then its actual syntax is this, so we can say line, and we can specify type explicitly. So this is line of type string, but like we can infer string, and if there is just one argument, we can convert it to it. That's default name. In Haskell, it will be underscore. And in Scala it's also underscore, but this comes from Groovy, I think it's called it. I think it's a bit more readable. So this is why it works. So there is one more thing to show, is that unlike previous tests, there is some magic going on, because this is not a function even. So that was the syntax. Here we basically have string literal, then we have curly braces and something's going on. So that's a bit odd. What's going on here, again, I'll show the full syntax. So the actual thing is operator overloading, which takes this thing. So our test class extends the string spec, and inside string spec class we have this extension function on string called invoke, which is also an operator. So what's going on here is this invoke can be replaced with direct call, which is just parents, and then because these parents take the lambda as the last argument, we can drop parents. So overall, it's kind of a bit too clever maybe, but it looks like we're calling some curly braces thing on a string. So this just shows how a combination of just extension functions, operator overloading, can make you call things on strings. So I'm not necessarily saying that's a great thing. I'm just saying this is how far you can take it. And there are even more complicated examples. So I'll quickly diverge then into list just to show, like, as the stuff I showed before, this is actually this Kotlin collection package. And here is defined list. So again, at compilation time, it's Kotlin collection. At runtime, it's compiled to platform collection. And here, list doesn't directly correspond to Java list, because these lists are read-only. So that's another lesson, I guess, which few languages took after Java was created, that default collections shouldn't be mutable. For this in Kotlin, there is, I highlighted this mutable list. So if you want to modify it, you need to use mutable list. Here, read-only means read-only. It doesn't mean it's persistent data structure though. So here's read-only list. Hope this all made sense. I'll inline things back, and I'll just move on to the kata. So we just read all the lines, and I guess we need to parse them somehow. So I'll do the simplest thing. I'll do just split, and I'll use regex to split it on one or more space. Bad idea, like this. So now in output, we should see lines like splitted into lists array. So now we can see that's the output. See commas between things, so that's why they were splitting. But we can also see this stuff at the top, and I guess stuff at the bottom, which we don't need. I'll do the simplest thing just to also show off things. So we can do drop 8 lines and then take 30. Then we'll get rid of those bottom and top things. Again, this drop and take, the extension functions defined in Kotlin, you won't find them in Java. So now we have just the lines that we need. Then next step might be is to extract only the columns that we need. For example, we could do column 1, which will be day number. So for random, I expect like 1, 2, 3, and so on. Yeah, so, but we want at least like 3 columns probably. There are no string literals in Kotlin, so that's the way to do it, is like function list off, and then it takes elements. So now it will be 3 columns. there will be a tiny thing. You can see this is the star, and there is one more star here. So need to remove this. It's typical enterprise development. You don't know what this means. Nobody knows. Let's just remove it. And now it's okay to have a list, but maybe we want it to be more semantically rich, so we will create a class to hold this, like value object, to hold these 3 values. So the way to do it in Kotlin is this concept of data classes. So I can say weather entry, and it will have value as day of type string, value max of type int, and value mean of type int. So data class, if you know, I think it's coming in C#8. It's a very similar thing called record classes. If you know Scala, it's like case classes. Basically, all this thing does is that it says automatically will define hash code equals into string. So here we can replace this list with that. So here's tiny problem is that it wants ints. It should be easy to convert like that. We're doing toInt. Once again, this toInt extension method in Kotlin, which just does this Java integer parseInt. But even this time, instead of typing this, we can do toInt. So looks much nicer to me. So I'm running it again, and now should expect those weather entries to be printed. So now it's a bit more readable, and finally to find in the actual entry, which there is a function to say mean by, and we can do max minus it mean. So there is no for each because there is now one entry, so I can say val mean entry. Println mean entry. So if I run this now, it should print the minimal entry. I'll do a bit of refactoring. So I'm putting all these lines in separate lines. No, it should be like that. No, it actually printed the right entry here, like 14. I'll do a little bit of cleanup. I'll add mean. That's an example why named arguments can be helpful, because this each2 to int is not readable. But instead of extracting variables, I'm just giving names to things, so I hope it's more clear. And now we should write an assertion probably, because this is like what we should do. And there is this function for this testing framework called should equal. So if I do this, the interesting thing is that like should equal is defined again somewhere in string spec, I believe. Yeah, somewhere. The interesting thing is the function defined on t, which is type argument. But the interesting thing is that it's infix. It has keyword infix, which means it can be, you can drop dot and parents. I'll do it again. So you can do this kind of thing. Yeah, it makes it a bit more readable, especially for tests, I think, because it separates what you actual and expected. So it's a bit more clear what's going on. So if I run this now, it should pass. And this is an actual assertion. Right. Arguably, this is still not that good because the original thing was about finding day. So we should probably assert on actual day, not on everything. Otherwise, it's a bit over-specifying the data. And if I do this, it kind of looks okay, except it doesn't compile. And this is because of nullability in Kotlin. So Kotlin is not happy about this because the actual type of mean entry is weather entry and question mark. And question mark, it's not exactly like C# nullables. Yes, I understand, and correct me if I'm wrong. In C#, the question mark is almost like syntactic sugar wrapping into nullable class. And in Kotlin, it's baked into the type system. So like similar to C#, the answer is to do like question mark dot, and then if mean entry is null, then the whole expression will be null. And then it will be null should equal 14 will fail. And by the way, it's nullable because we do mean by, and mean by on an empty list is nothing. So there is no way to be sure that there is something. So that's quick divergence into Kotlin type system because of nullability. So that's Nat Price's blog post. With his permission, I'm showing it. So just really quickly, just looking at the picture. So the way it works, at the top of type hierarchy, there is any, which is like string. Classes can inherit from any. Then there are interface. So there is single inheritance, just like C# Java, but multiple interface inheritance. So you have tomato, it implements 2 interfaces. I can go and sell it. And all classes implement any. Now we move on to nullable types. So nullable types, they basically copy the actual type. So if we have fruit, there is fruit ? And there are 2 parallel type hierarchies. And also classes without question marks, so non-nullable are subtypes of nullable. So that's the whole thing, like hierarchies kind of connect to each other in this way. And it makes sense because nullable type has 1 more value, so it's like superset of normal type. Then there is unit, which is like void. I'll skip this. Then at the bottom, like in a few other languages, there is type nothing. I won't go into details, but it can be useful to have nothing because it basically means termination of execution in the program. So it can be useful. And then there is nullable nothing. And there is also nullable unit. Confusing. No, it's not really confusing. In this way, type system is quite well designed and symmetric and so on. So in this case, going back to the problem, it was nullable entry, so don't need to specify this. So the best way is probably the question mark dot here. And this is how we found minimum day. So now we can move to part 2, find team with minimum goal difference. Find team with minimum goal difference. So it's similar. We're using this string on string. We're using overloaded operator just to show the data for part 2. That's football. Very similar teams inside text file. So I'm not going to type the whole thing. I'll cheat a little bit. I'll just paste some code, which is almost what we need. So this is going to be football data. So it's like the idea is absolutely the same. So we have this data class for team entry. It will have name, goal for against. Then we have this code, which loads the file football.dat, at which we just looked. Then we read lines, drop 5, take 21. Then there was one line which was with this dash, 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 right? Then we skip this line. Then we do split. Then we do map, and then same thing, team entry with column numbers. So it's like the same stuff, basically. Then slightly different, we mean by absolute value, because there is no min max. It's just goals. And then we do dot printed from hello world. So hopefully it will just print the right team. So if I click, yeah, that's the team entry. I know this is correct. So we can also do here min entry. Then remove this and min entry. It should be name, I think. And it should equal Aston Villa. So that's compilation. So that's the thing. Now, if we want to move on, we can do part 3. Or, yeah, we can try part 3. So basically now this works, and the third bit is to extract as much common code as possible. So you can see this is quite similar. So my idea would be just to make these bits of code as similar as we can, and then we can extract them and like see how it goes. The obvious difference here, the first difference is like we drop in different amounts of lines and doing this here. So I would attempt to do the following thing. So there is a function built in Kotlin called map not null. It basically will create an entry, but then here we'll do null on exception with null on exception. And this is some other function. So basically what's going on here, if this parsing conversion to integer will explode, this with null on exception will catch the exception and return null. And this map not null will filter out nulls. So this map, it maps and also filters out nulls. There is an alternative way to do it like this, for example, to filter not null. But they're equivalent, so I'll keep map not null. I'm not saying that's the cleanest way at all, but it's like it illustrates a few things. So with null on exception, I defined it myself in this file. That's what it is. So it's inline function. So that's another keyword in Kotlin where you can tell compiler to definitely inline this function everywhere. yeah, there are use cases when it's useful. And then it's a function which takes this f, so it's high order function, and basically just calls f in try catch, ignores the exception, and returns null. So this will now kind of work for our file. So I removed these 2 lines here. Just remove them and run tests again, so hopefully it should work. So it still works for football. So now I can do the same thing for weather. So do map not null. Do with null and exception. So I can drop this thing now. So then there is this difference, which we remove this star for weather, but don't really remove for football. Probably can remove in both, not gonna hurt. And then the next difference is creating the entry, which I don't think can be easily refactored, so I would extract it as a function outside of thing. Then we move to mean by, and mean by they're different because those 2 entries are different. This is where it would maybe help to have some super type for these 2 data classes. And so the naive attempt might be just these 2 data class, let's say call it entry, and it has some kind of key of type string, and then this data class will implement entry and say this is a day as a key. There is a problem. It's not going to work at all because Kotlin says the type is final, so it cannot be inherited. So it says that entry is final, which cannot be. That's the interesting thing, is that unlike many other languages, in Kotlin all the classes are final, and all methods, everything is final by default. So if you want to extend, you need to make them open. So I'm using this, making keyword open. Then there is next problem. Open and data is just modifier. It's like they don't work together. So if I remove data, it becomes all fine. But then it kind of defeats the purpose of why we're inheriting from day anyway, and then pass in. So it's kind of questionable. So I guess in general, I would do it maybe this way. So I would define interface and then inherit from interface, implement interface in classes. So something like this. So here what we're doing, we're saying this class implements interface, then there is keyword override, and it overrides the value. Value here means read-only field on an object, and in reality it would be just a getter. So the same thing with so we need one more thing, I guess, here called criteria, and then to implement this as well. And this can be max minus min. And then the same thing we can do for team entry and implement those 2 things. You might notice here this get thing. This is because Kotlin also has getters. I'm not going to go into it, but yeah, it also has getters and setters like some other language. No, apps, not max. And then goal against. And so, but you can see where it goes, the whole thing. So now these classes can be replaced with entry. So for example, here instead of max, I should be able to do criteria. And here instead of this math apps, I should be able to do but it criteria. So I'll extract then this whole thing into a function called find mean entry in, and then can extract this file name. File name. So then the thing which is still specific to each case is this. I'll extract this as a function. It will break right now, I think, because it should take a list of strings and return an entry. So here what's going on is this should be like that. And it returns an entry, not team entry. And this is a key. So with this, that's the finding minimum team entry. So it basically takes the file name and then takes this closure, which is again outside of parents, and then just creates team entry. So if this runs, then the same thing should be applied, so it still passes. So the same thing should be applied to this case. Then you can do this, delete, delete. This is key. This should still work. Yeah, it did pass at the bottom. So this is basically the refactoring. It's like one way to do this code cutter. Yeah, if you have any questions or comments, tell me. Okay, I'll switch back. This was the collection thing I showed, but it doesn't matter. Well, this is what we looked at. It was quite a lot. Kotlin collections, lambdas. Thing I didn't mention is that there are no checked exceptions, because in Java, normally, if you read from file, you will have to catch some exceptions. Again, I think all languages, all popular languages, so JVM dropped this idea for better or worse. Then there are data classes. We looked at nullable types and Kotlin test with this tricky invoke thing on the string. So again, random joke. This is how you do SQL injection on speed cameras. Right. And this is it. I'll do a little bit more talking. So obviously there is homepage for Kotlin, lang.org. Right. There is a website where you can type some code and run it online with zero installation. Then there is like the best guide to learning a little bit of Kotlin is this Kotlin Koans, written by JetBrains people. It's pretty good. If you don't know a Koan, it's a bunch of failing tests, and you need to complete the task, and then the test will pass. You can clone it from GitHub or try it on this website. It's really good, I think. I did 99 Kotlin problems. Basically, there was this. Well, somebody wrote 99's prologue problems. Then it was transformed to Scala. I did the Scala one, then I redid it in Kotlin. I did it too many times. Then there is great site kotlin.link. It has a bunch of stuff if you're interested. Obviously, there is Twitter. There is a blog for Kotlin. The best thing about this blog is that it showed Kotlin existed for many years, and they've been blogging all along. So if you read all the old blog posts, you will see evolution of the language. So like there were quite a few interesting things, and the way it's documented is really good. There's also Kotlin action book. It's pretty good. There is this Discuss forums. There is Slack. Slack is quite nice. You can see on this screenshot there's 5,000 people. Now it's 15,000 because I took this screenshot a long time ago before Google approved Kotlin as first-class language for Android. Then there was Kotlin Conf in San Francisco, and there will be somewhere next year, or this year, sorry. There will be another conference. It's not announced where yet. I hope it's in Europe, maybe here. And then there is the Kotlin Future. There will be 1.3 release. There are core routines which are already released, but the interesting bit is library support for coroutines. And then there is Kotlin Native. As I said, this Kotlin is multi-platform. So right now, Kotlin Native actually works. You can use it, but it's not production quality. So hopefully it will be maybe in a year or so. It will be interesting. And this is pretty much it. Thank you for watching.